You are standing outside right now and the sky looks fine, maybe a little breezy, nothing that would make you cancel your plans. But somewhere inside a weather office, a meteorologist just watched a small wind advisory turn into something much bigger. And within the hour, that same warning covers 3 times the land it did before. This is not a glitch. This is not an overreaction. This is exactly how dangerous wind events actually behave. And once you understand why a wind warning suddenly grows, you will never look at a weather alert on your phone the same way again. Most people assume a wind warning is like a fixed box drawn on a map. They think forecasters pick a shape, stamp it down, and wait for the storm to arrive inside those lines. That is not how it works at all. A wind warning is a living, moving prediction. It grows, shrinks, shifts, and sometimes explodes in size because the atmosphere itself is doing the same thing in real time. When a warning suddenly expands, it almost always means the system driving it has become more organized, more powerful, or more unpredictable than the models expected just hours earlier. To understand why this happens, you need to picture the atmosphere as layers of air moving at different speeds and directions, stacked on top of each other like invisible rivers. Near the ground, wind is slowed down by trees, buildings, and friction with the earth. But a few thousand feet up, wind can be moving twice as fast, sometimes even 3 or 4 times as fast. Most of the time, that fast air stays up there, minding its own business. But when a storm system punches a hole through the atmosphere in just the right way, that fast-moving air gets pulled straight down to the surface. Suddenly, the wind you feel on the ground is not the gentle breeze from yesterday. It is a slice of that high-speed river dropped onto your street. This is one of the biggest reasons wind warnings expand so quickly. Forecasters are not just watching a storm move across a map. They are watching how much energy is stacked above that storm, waiting to be released downward. When new data comes in, showing that upper-level wind is stronger than expected, or that the pressure difference between 2 air masses is widening faster than predicted, the entire warning area has to grow to keep up with where that energy could realistically reach. It is less like predicting where a ball will land, and more like realizing the field it could land on is suddenly twice as long. Another major driver behind these sudden expansions is something meteorologists call a pressure gradient. Wind exists because air is trying to move from high pressure to low pressure. And the bigger that difference, the faster and more violent the wind becomes. When a strong high-pressure system and a strong low-pressure system end up sitting close together, the atmosphere basically becomes a pressure cooker with the valve fully open. If new readings show that gap tightening faster than expected, forecasters know the wind will not stay contained to one small region. It will rush outward following the path of least resistance, and that path can stretch across several states in just a few hours. There's also a phenomenon that plays a huge role in these expanding warnings, and it barely gets talked about outside of weather circles. It is called a wake low, and it is one of the sneakiest wind producers in the entire atmosphere. Most people assume the dangerous winds during a storm happen while the storm is directly overhead, with lightning flashing and rain pouring down. But some of the most destructive straight-line winds actually happen after the heavy rain has already passed, on the back edge of a storm system. As a line of thunderstorms weakens, a small pocket of unusually high pressure can form right behind it. That pocket acts almost like a slingshot, and it can fire off wind gusts that are even stronger than anything produced while the storm was still raining. Because wake lows are notoriously difficult to predict with precision, warnings tied to them often start small and then get upgraded or expanded rapidly, as radar data starts revealing exactly how strong and how wide that wind pocket has become. This unpredictability is honestly the heart of the entire issue. Weather models are incredibly powerful, but they are still working, with probabilities, not certainties. A model might show a 50% chance that a certain area sees damaging gusts, and forecasters have to make a judgment call about where to draw that warning boundary. As new radar sweeps, weather balloon readings, and surface observations come in every few minutes, that picture sharpens. Sometimes it sharpens in a way that shrinks the danger zone, but often, especially with fast-moving and intensifying systems, it sharpens in a way that reveals the threat is bigger than first thought. When that happens, waiting around to be extra sure is not an option. The responsible move is always to expand the warning immediately and let residents know sooner rather than later, even if that means adjusting the boundaries again in another hour. There is also a structural reason these warnings can grow so dramatically, and it has to do with how storm systems interact with the terrain and other weather features around them. A single line of thunderstorms moving across flat, open land can behave in a fairly predictable way. But the moment that same system runs into a mountain range, a large body of water, or even just a shift in temperature between 2 regions, its behavior can change entirely. Wind can accelerate through mountain passes, funnel along valleys, or get re-energized as it crosses over warm water. Forecasters are constantly adjusting warnings, not just based on the storm itself, but based on how the landscape ahead is likely to reshape that storm's power. This is part of why a wind warning that looked calm and contained on the western side of a region can suddenly stretch dramatically once it reaches new terrain. Now here is the part that should really change how you treat these alerts going forward. A wind warning getting bigger is not a sign that forecasters are guessing or overreacting. It is a sign that the system is behaving exactly the way dangerous wind events are known to behave, becoming more organized and drawing in more energy as it travels. The safest people during these events are not the ones who wait to see how bad it actually gets. They are the ones who treat every expansion of a warning as new, timely information and adjust their plans immediately. That means securing anything outdoors that could become a projectile, staying away from large trees and power lines, and avoiding travel through open areas where high-profile vehicles can be pushed off the road by sudden gusts. If you have ever driven through a sudden burst of wind that seemed to appear out of nowhere and shove your car sideways for a second, you have already felt firsthand exactly what these expanding warnings are trying to protect you from. That is not random bad luck. That is very likely a wake low, a tightening pressure gradient, or a burst of upper-level energy reaching the ground exactly where you happen to be driving. The scary part is that these events can develop and intensify faster than most people expect, which is exactly why meteorologists would rather expand a warning too early than leave you unprotected while they wait for perfect certainty. Before we go further, if you are enjoying learning how these weather systems actually think and evolve behind the scenes, go ahead and hit like on this video right now, and subscribe so you do not miss the next breakdown like this one. Another detail that rarely gets attention is how much these expanding wind warnings depend on teamwork between different layers of forecasting. Local weather offices watch immediate radar returns and ground reports. National centers track the broader pattern across multiple states, and satellite data fills in the picture from above where ground radar cannot see. When all three sources point toward the same expanding threat, warnings jump dramatically within a very short window. It is not one person guessing. It is layers of independent data converging on the same conclusion at nearly the same time. It is also worth mentioning why these warnings tend to expand rather than simply move. A moving warning would suggest the danger is just shifting location, staying the same size but sliding across the map. An expanding warning tells a very different story. It means the total footprint of the threat is growing, which usually points to the storm system gaining strength rather than just drifting along on autopilot. This distinction matters because a growing warning often comes with stronger gusts, more widespread power outages, and a higher chance of structural damage compared to a warning that is simply sliding steadily across a region without changing size. For anyone living in an area prone to these sudden wind events, the smartest habit you can build is treating every notification, not just the first one, as brand new information. Do not assume the warning you saw first thing in the morning is the final word on what is coming your way. Weather offices update these boundaries constantly because the atmosphere itself refuses to sit still. Checking back every couple of hours during an active weather day, especially when skies look uncertain, can be the difference between calmly bringing your patio furniture inside and chasing it down the street after the gusts have already arrived. There is one more piece of this puzzle that often gets overlooked, and it has to do with timing rather than raw power. A wind event that arrives during the middle of the afternoon behaves very differently from the exact same system arriving overnight. During the day, the sun heats the ground, which stirs up the lower atmosphere and actually helps mix some of that fast upper-level wind down to the surface more evenly. At night, the ground cools, and the lower atmosphere becomes calmer and more stable, almost like a lid settling over everything below it. That stable lid can trap a huge amount of wind energy above the surface, and when a strong enough system finally breaks through that lid, the sudden release of wind can be even more violent than a daytime event with similar overall strength. Forecasters watching this kind of setup unfold at night often have to expand warnings quickly once they see clear signs that the lid is about to break, because the transition from calm to dangerous can happen in a matter of minutes rather than hours. This is also why many of the most damaging wind events in recorded history have struck well after sunset, catching entire communities off guard while they slept. A warning that expands overnight is not being dramatic. It is responding to a dangerous timing pattern meteorologists have studied for decades, where stored-up daytime energy gets unleashed all at once after dark. If you ever notice a wind warning growing rapidly in the evening or overnight hours, treat that as an especially serious signal. It also helps to understand that these warnings are not written for meteorologists. They are written for you, for your family, and for every person trying to decide whether tonight is the night to bring the trampoline inside or move the car away from that big oak tree. Every expansion represents real people working with real data, trying to give you the most honest picture possible of what your area might experience in the coming hours. At the end of the day, an expanding wind warning is really just the atmosphere being honest with us faster than we expected. It is telling forecasters, and by extension, telling you that the danger is bigger, faster, or more widespread than anyone originally thought. Respecting that expansion instead of dismissing it is one of the simplest ways to stay safe when the sky decides to show its full strength. So the next time your phone buzzes with an updated wind warning covering a much larger area than before, do not roll your eyes and assume it is overkill. Take it as a sign that the storm is doing exactly what storms do best, growing into whatever room the atmosphere gives it. If this kind of deep weather breakdown keeps you hooked, make sure you are subscribed so the next one lands right in your feed.